Good morning, everyone. Today, I'm just going to introduce section 3.1. Okay, some of you already started chapter 3. Just don't forget, the test 1, which is chapter 1 and 2, is due by tomorrow. Okay, the 21st is due by tomorrow. So I'm going to go ahead and start chapter 3 in here. Okay, so I want to just make one section today only. All right. Section 3.1 is about a complex number in here. Okay. So the reason is we introduce the complex number because in a quadratic equation, sometimes we don't have a real solution in a real number system. All right. So this chapter is all about quadratic equation and the function in here. All right. So we're gonna go ahead and introduce this section before we get to the real quadratic equation. Okay. So first, what is a complex number? Complex number we also using I. Okay. So complex number is also called imaginary number. That's why you're using the first initial I for the complex number in here. The reason we have a complex number because if we want to find okay, I'm giving you a graph in here, right? So if I make this is x, this is y, and I want to find this graph, okay? So if I have this graph in here, I want to say, how about what x-intercept in here? All right, so if I want to find the x-intercept, that means the graph will have to pass the x-axis in here, right? But I don't have a graph, this graph will never touch the x-axis. So what happened in here? Oh, that means this one don't have a real solution in here, okay? So if we ask the make a y equal to 0, right? In order to find the x-intercept here, y must be 0. And since this doesn't cross the x-axis, so y never goes to 0. Y is always positive in here. So that means this graph don't have a real solution if you want to make a y equal to 0. Okay, so the complex number is using to solve this type of situation in here. Okay, because the graph does not cross the x-axis, therefore this has no x-intercept in here. And since you don't have an x-intercept, that means we don't have a real number of 0 in here. Okay, so that is the complex number system in here. All right. And we said that earlier, the complex number is also called imaginary number. Okay, complex number, we're using I. This is the definition for the I. So I is defined as the square root of -1, right? When we talked the domain earlier, okay, so remember on the chapter 1 and 2, we always talk a domain. When we talk the domain, that means that is always in a real number system. Okay, domain, we talk the domain is in a real number system. That's why when we have something under the square root, right, in order for this to have a real solution, we want to make sure everything under the radicand has to be greater than or equal to 0 in here. Okay, how about if this is not greater than or equal to 0? You're gonna end up with this kind of situation. So this situation is called the imaginary number, imaginary. Okay, imaginary number in here, and you don't have a real solution. That's why the mathematician define this one right here. Let I equal to square root of -1. Okay, and then if I square both sides, right? Look at it. If I square both sides in here, all right, what do we get? We can square both sides on the equation, right? If I square both sides, I got an I square, and then the square root and square cancel out. So I get an I square equal to -1. So in this section, we're gonna use this a lot. Actually, in this chapter, for the quadratic equation, we're gonna use this a lot in here. Okay, so this is called the definition for the I. So next time when we see the I, when we have a square root of -1, we have to simplify into I. When we see the I square, we have to simplify as -1. All right. So at the beginning, you might want to take a note for these two because we're gonna use quite often in here. Okay. So now let's look at this one right here. How do I express this one in terms of I? If you do the homework and then if you have a square root of -7, you cannot leave this one as a final answer. You have to write down this one is square root of -1 times the square root of 7, right? And then square root of -1 is I. So I have I square root of 7 in here, okay? So that is this one right here. You can write down as I square root of 7, or you can write down square root of 7I. Just make sure don't put the I inside the square root, okay? This one is a wrong one. This one is a wrong one. So that's why we sometimes recommend you to use this one, write the I first, so you don't accidentally, especially, you know, when you typing, you might kind of didn't put a cursor outside, right? And then type the I right here. And then the MyNet Plus will counter you wrong because you didn't know. I didn't write why this one counted wrong because you didn't put a cursor out first. You have to put a cursor move out first and then type the I. Okay, don't put I inside the square root because that will be the wrong answer in here. So that's why we kind of sometimes ask you to just go ahead and type I first so they can avoid that kind of accident. Okay. If I have a square root of -16, same thing, you have to separate into square root of -1 first, and then times the square root of 16, right? And then square root of -1 is I in here. So that's why you got to answer as 4I, okay? So that is the final answer, should be 4I in here. Well, we usually don't write down I4, right? So we like to write down 4I, even these two are equal, but you know, we want to write down called a standard format, okay? You write down A plus BI, that kind of thing. We like to put I at the end, but this one, we recommend you to write this one in here because we don't want you to put an I inside the square root by accident, okay? So that's the purpose. All right. Let's look at negative square root of -13. What happened? Well, if you have a something negative outside the square root, you carry over. Okay, so this one doesn't have anything to do inside the square root. You cannot say negative cancel out. No, inside and outside the square root, you cannot do the operation. Okay, so this one is outside the square root. You have to carry over. You have to carry over this negative all the way. All right, so you can do the square root of -13 on the side and just carry this one first. Okay, let's see what is the question here. Okay, so my audio isn't working. I have a question. I'm not on the track. I have passed due assignment on my lab class. We have a effect on my grade, or do we reduce point or submitting the late assignment? Well, Alicia, one thing is no, we don't take any point off. Okay, so don't worry about that. As long as you catch up, that's fine. You don't have a point off. You can still get the full point. You even, you know, we put the due date as a reference date. Okay, so even you can still do the assignment past the due date, but you know, you kind of know you a little bit behind, so you kind of need to catch up. But one thing is we don't take any point off. Okay, so don't worry as long as you catch up. All right, so no point off, no point off, no point off for any past due. Okay, so you can still do that in here. All right, okay, good question. All right, so let's come back to continue to this one right here. Okay. If we have square root of -13, right? We will need to have a square root of -1 times the square root of 13. And then this square root of -1 is I. So we have I square root of 13 in here, okay? And remember, this outside negative, you have to carry over, nothing to do with the inside one. So we have a negative in here, we have a negative in here. So that's why the final answer, you still have a negative, because we carry over this all the way down here. So your answer will be negative I square root of 13. Or or write down I at the end, but just make sure this I has to be outside the square root, not inside the square root, okay? All right, so now is this one right here. If you have a negative square root of -64, okay, let me close the window because outside is too much noise. Okay, that's better. All right, so if you have a square root of -64, same thing, you will still need to carry over here. You will still need to carry the -1 all the way. Look at that, carry the -1 all the way here, all the way. So the outside negative has nothing to do with the inside the -1. And then we're gonna have to separate this square root of -1, right? And then square root of 64. So square root of 64 is 8. So now we have an AI. And of course, you have to carry the negative all the way. So we're gonna have a final answer as negative AI in here, okay? So that should be quick and easy in here. Not so quick and easy is something like this one right here, okay? If you have a square root of -48, what happened? Well, we're gonna have a square root of -1 and square root of 48, right? And square root of -1, we know is I in here. But now this one is not a perfect square. 48 is not something perfect square. So what do we do? Well, we have to separate. So I showed some people earlier this one right here, right? If you do not know this one, you can separate into 16 times 3, which is very quick. If you kind of familiar with the number, you have a 16 times 3, you got 48, right? And 16 square root will be 4. And 3 is not a perfect square, so you have to leave it inside. All right, so we're gonna have a 4i square root of 3 or 4 square root of 3i. Make sure I is outside the square root, okay? But if you do not know this one is 16 times 3, what can you do? You can see this one is this one is an even number, right? Even number, you can always divide it by 2. So I'm gonna break down by 2. So this divided by 2, I got 24, right? And then divided by 2 again, I got 12, okay? And then divided by 2 again, I got 6. And then divided by 2 again, I got 2 and 3. All right, so now I have this one is 3, right? So what can I do here? I counted 1, 2, 3, 4. So this one will be 2 to the 4 power times 3. Look at it. So 48, I can write down 2 to the 4 power times 3, right? And then when I take the square root, so I can take the square root for 2 to the 4 power times the square root of 3 in here, right? And 2 to the 4 power square root is kind of like a 2 to the 4 divided by 2, right? So this is 2 square. Okay, so 2 square is what? 2 square is 4. So 2 square is 4. So and of course, I have to keep the square root of 3, right? I have to keep the square root of 3 all the way. Okay, so I have a 4 square root of 3 in here. Of course, don't forget square root of -1 is I. Okay, so you can break down in here, or you can think, oh, that is 2 to the 4 power. It is 16, right? So this is 16 times 3 in here. Okay, so you can have a little bit breakdown in here if you do not know how to simplify square root of 48. All right. So same thing, if I have given you one more example in here, if I have a square root of -27, what do you do? Well, I have a square root of -1, -1, and then square root of 27, right? And then you can think like a 27, you can divide by 3, okay? So divided by 3, you got 9, divided by 3, you got 3 and 3. So now you can write down this one as 3 squared times 3, 3 squared times 3, right? In here, and 3 squared will be what? 3 squared, take a square root will be 3. So this will be 3 square root of 3 and then I in here. Make sure I is not inside the square root, okay? So that is how you do this type of equation in here. Next one, we want to give a quick calculation is complex number has a standard form. This standard form is called A plus BI, okay? A and B are the real number part. A is said to be a real number part for this A plus BI, and B is said to be the imaginary part for the A plus BI. So for example, if I have a 1 plus 2i, that is called a standard form for this complex number, okay? And 1 and 2 are the all real numbers. So my A is 1, my B is 2 in here. If I don't have a 1 plus 2i, if I only have a 2i, that means this is called a pure imaginary number, okay? Pure imaginary number in here. So we can do the calculation. Look at it. If I have a 2 complex number in this case, we can do the addition, we can do the subtraction in here, or we can do the multiplication, we can also do the division. And that is all this section about, okay? So if I have an addition, what do I do? Well, if I have an addition in here, I can get rid of parentheses, right? Get rid of parentheses. I don't really need a parenthesis here. And I add a real number part, together, okay? Add a real number part together, so 8 plus 3 will be 11, okay? And I go to look at, this is called imaginary number part. So I have a 6i plus 2i. So this one is just kind of like a correct like an item, okay, like a term in here. Just like if you have a 6x plus 2x, what do you get? Well, if I have a 6x plus 2x, I got ax. Same thing as I, okay? So if I have a 6i plus 2i, I put an I outside, I just using 6 plus 2. So I got ai in here, okay? So this calculation should be pretty straightforward. And similar with the subtraction here, subtraction, just make sure you have to distribute this negative in, okay? When you get rid of parentheses, you have to distribute a negative in here. So the first one will be still 4 plus 5i, okay? I like to write down this one one step, and then minus 6 in here. And then minus negative 3i will be plus 3i. Okay, so I like to get rid of parentheses first. So minus 6 and then negative become positive. So now we're gonna add a 4 and negative 6 together. Add a 4 and negative 6 together. You got negative 2, right? And then we're gonna have 5i plus 3i. You got ai in here. You got ai in here. Okay, so we like to write down a plus bi form. Instead of write down, we don't like to write down ai minus 2, right? Even they are the same. We like to write down a in the front, plus bi. So we prefer to write down negative 2 plus ai, called a standard form in here. Okay, so that's addition, that's subtraction. And we can also do the multiplication in here, okay? But when we do the multiplication, we have to be very careful. So one thing I want to emphasize here is when we have a and b are the real number and they are under the square root, right? We can multiply, we can take the root outside, multiply a and b together. If a and b are not a real number, what happens? We cannot do this one. We cannot do this one right here. So what does that mean? If I have a negative 4 times negative 9, right? This one If, okay, let's do the real number first. If I have a square root of 4 times the square root of 9, these both are the real number, right? And I can multiply these two together, says 4 times 9 is 36, and then 36 square root is 6. So I can multiply A and B together first, and then take the square root, which is 6. This is exactly right, okay? But when I have a square root of negative 4 times the square root of negative 9, this is not a real number because this is under the square root, is even root. Even root radicand cannot be negative, right? But this one we have a negative. So this one is not equal to, you cannot write down, say, well, I'm going to have a negative square root of 9 times negative square root of square root of negative 4 times negative 9, and then you're gonna get a 36, and then you're gonna get a 6. No, this is not equal to this one. Okay, so what should we do in here? If you encounter this kind of situation, you will have to write down square root of negative 1 first. So this one we will have to write down square root of negative 1 times square root of 4. And then multiply the second one similar. We're going to have a square root of negative 1 times the square root of 9. Okay, each one we have to separate this one. And square root of negative 1 is I. Okay, and then square root of 4 is 2. Okay, and then we have another square root of negative 1 here, which is I again. And then we have a square root of 9, which is 3. So what is my answer in here? My answer here will be 6I squared. Okay, I times I will be I squared. So this to find out I squared, we have to simplify as a negative 1. So this whole thing is negative 6. Look at that. This whole thing is negative 6. It's not equal to 6. Okay, so that is very important. That is explain this one right here. If you have a square root of negative 4 and square root of negative 9, you will have to put a square root of negative 1 separately first before you do the calculation. Okay, this one is very similar in here. This one is very similar. Look at that. Square root of negative 16, you will have to separate square root of negative 1 out times the square root of 16. And same thing as this one right here. We have to put a square root of negative 1 and then times the square root of 25, right? And then this one will be I, this one will be I, this one will be another I in here. And then square root of 16 is 4, square root of 25 is 5, okay? So multiply this one right here, we're gonna have a 20I squared, and I squared is negative 1, I squared is negative 1, we have to simplify. So we're gonna get an answer as negative 20, okay? If you got a positive 20, that is a wrong one, all right? So that is, this one is very important that we need to calculate separately, okay? And same thing, we're gonna have a multiplication. So when we have these two, when we don't write anything in the parentheses, that means multiply. So how do we multiply this one? We call it FOIL, F-O-I-L, FOIL, okay? 2 items times 2 items. When I have 2 items times 2 items, I should got 4 items. Before you combine the like item, I should got 4 items, okay? And then you can see the FOIL is 4 items, okay? So how do I FOIL it? 1 times 1, let's call the fourth term, right? 1 times 1 is 1. All right, and then let's see, 1 times 3i, we are giving you 3i in here. Let's call the outer term, right? And then we're gonna have an inner term, 2i times 1. So 2i times 1, I got 2i, okay? And then the last term here is, what's the last term? This is the last term for the first parenthesis. This is the last term for the second parenthesis. So this is called the last term here. And then I have a 2i times 3i, I will get a 6i squared. Okay, so that's 4 items. That's called a FOIL in here. All right, you can always do a little bit of drawing in here, and then you got a 4 items. And of course, we have to simplify this one right here, right? So we're going to have a 1 plus 3i plus 2i is 5i. Okay, the like term, correct the like term in here, plus 6 times I squared. I squared is equal to -1. So we have to simplify this one right here. Okay, so I will have a 1 plus 5i minus 6. Okay, minus 6 in here. And then these two are the like terms, so I have to combine these two together. So 1 minus 6 is -5. So I have a -5 plus 5i. Okay, and that will be the final answer for this one. Okay, we have a -5 plus 5i in here. So using the FOIL, multiply it in. Okay. All right, how about if you have a perfect square? If you have a perfect square, you don't remember the perfect square formula, you can do the FOIL, okay? We actually have a perfect square formula called A plus B. This is a perfect square formula, right? This is called A squared plus 2AB plus B squared, okay? That's a formula for that. But if you don't remember the formula, you can FOIL it in. And if you have a minus b perfect square, that's a perfect square. This just change it to negative. Everything else is the same. All right. But if you don't remember the formula, we can do the FOIL. So what does a perfect square mean? Perfect square, that means 3 minus 7i times itself times 3 minus 7i in here. Okay, so this is a base stay the same. You multiply the 2 times for this parenthesis. So that is this one. Now we can do the similar. We can do the FOIL in here. Okay, we can do the FOIL FOIL. Okay, so 3 times 3, we got a 9 in here. Okay, and then 3 times negative, you have to consider this one is -7i. So 3 times -7i will be -21i, right? And then this one right here, the inner term, okay? So the inner term, we have a -7i times 3, that's another -21i, okay? And then the last term here, so where's my last term? Well, this is my last term here. So last term, you remember this is negative in the front. Most have a negative in the front. So -7i times -7i should be plus 49i squared. Okay. All right. So now we combine the like term in here. So what's the like term? Well, these two and these two are this one and this one are the like term. These two guys are the same. All right, so we're gonna combine these two together. So it will be minus 42i. Okay. Negative, negative. These both are negative. You add a number together and then keep the negative. All right. And then plus 49i squared, you have to simplify, is -1. So now I have a 9 minus 42i minus 49. Okay. And then this 2 is another like term. 9 minus 49, you got -40. Okay. And then minus 42i. So that is the final answer for this one. Okay. So this one I using the FOIL. I using the FOIL in here. I can also using the formula. Okay. So what is the formula in here? Well, the formula for the perfect square here is the fourth term. Okay, this is my A. So fourth term square, okay, minus 2 times 3 times 7i, and then plus 7i squared. Okay, this is called using A minus B perfect square. Okay, I have an A squared minus 2AB plus B squared. All right, so A is 3. So look at that. I just match the formula in here. Okay, and then this will give me you the same answer. So this is 9. 2 times 3 is 6 times 7 is 42. So we have a 42i, and then plus 49i squared. Okay, And we know I square is what? I square is -1. So this one you're going to multiply by -1 in here. So we will have a 9 minus 42i. Okay. And then minus this one is 49. All right. And then similar, you create a like term, right? These two are the like term. So you have a -40 minus 42i, minus 42i. So you got exactly the same answer, okay? So you can either using the formula or you can using the FOIL in here. So this, I giving you two ways to do this one. If you don't remember this formula, you can do the FOIL, okay? Just like this one, do the FOIL. All right, any questions? Anyone has any questions? All right, last thing, last one for this one right here. We just did this earlier, okay? Simplify the I power, okay? So if you have a power more than just one, what do you have? When we have an I, we know it's the square root of -1, right? And then if you have an I square, what happened? Well, I square is -1, right? How about if I have an I to the 3 power? Well, if I to the 3 power, I can write down as I squared times I, right? Remember, we have algebra. If you have a to the m times a to the n, what do? You have a same base, right? And then this power multiply, you keep the base, so you have an n plus n in here. All right, so through it, I can think it's 2 plus 1, okay? So I can break down into 2 times I to the 2 times I to the 1. And then 2, this is I to the 1 power, right? So 2 plus 1 is equal to 3. So now we have a I square is -1, so I cube will be just -I in here, okay? How much is I to the 4 power? Well, I to the 4 power, you can think it's I square times I square as well, right? So you have a -1 times -1, and you got a +1. All right, that's one way to look at it. Another one to look at this one right here is you have a I square and then square them, right? 2 times 2 is 4. So what is this one? This is another algebra here. So that means if I have a to the m and then times n, what do we do in here? Well, this is just only 1 base, 2 power. So if this is the case, 1 base, 2 power, what do? You multiply the power together. This is multiply, not addition, but multiply. You use m times n, okay? So these two formula from the algebra, you have to be very familiar when you do this type of question, okay? This one is you have a 2 base, I'm sorry, 1 base, but 2, in 2, look at it. If you a to the m and then times another a to the n, you add a power together, right? You have a and a in here. This one, you only have a 1a, 1 base, and then you have a 2 powers together, you multiply the power, okay? So that's why you can write down this one either this way or this way, giving you the same answer, okay? All right, so write down this one. Sometimes, it's a little bit easier to calculate a higher power, right? So for example, if I want to calculate I to the 100 power, what happened? Well, I to the 100 power. Now I'm gonna write down this is I square, right? I square. I square to the what? 50 power. Look at it. I to the 100 power. I can have a 2 times 50. 2 times 50 is 100. Okay, so this will be a little bit easier to write. And then I square is -1. Okay, and then -1 to the 50 power. How much is this one? Oh, this will be just +1, right? 1 to the any power is always 1. And negative to the even power, this is the even power, right? If you have an even power, if you have a negative number to the even power, it's always positive. Okay, how about if I have an I to the 101 power? Well, I to the 101 power, I can have an I to the 100 power times I. Okay, times I in here. And I already calculate I to the 100 power is 1, right? So this will be just 1 times I, or will be just I, will be just I in here. Okay, so you can calculate this 1 to the any power in here. Similar, if I have I to the 5 power, right? I can break down I to the 4 power times I. or I square square, okay, and then negative 1 square is positive. So this will give you positive I. So basically, if you have an I to the any power, you can have a, you can, if you have an I to the n power, n is greater than 1, right? When n is greater than 1, you will just have one of these answer, either negative 1 or positive 1 or I or negative I, okay? You can always combine into one of these answer for the I. All right, but we don't really use that much. We use this one the most, using I squared the most, okay? All right, another one is very important here. It's called a conjugate, okay? This will be my last concept for today. All right, so what is a conjugate in here? Conjugate used a lot in algebra. If you have a plus bi, the conjugate will be a minus bi. So that means look at the A and A are the same, right? B and I, BI are the same. The only thing difference here, this is plus, this is minus, okay? If this is the case, we call this is a conjugate. The only thing you have a two conjugate is I and a square root. So where's the square root in here? If I have a 1 plus the square root of 2, I also have a conjugate. So where's the conjugate for this one? This one will be 1 minus the square root of 2. Okay, so very similar to this one right here. So if I have 1 plus 2i, what is my conjugate? Well, my conjugate will be 1 minus I. Okay, so that's called a complex conjugate in here. If I have a negative 3 plus 7i, what is the conjugate? Well, my A here is negative 3, right? My B here is 7i. My B here is 7i here. So I have A plus BI. My conjugate will be A minus BI. So change this one into minus in here. Okay. If you have a negative, this is A minus BI. If you have A minus BI, the conjugate will be A plus BI. So just change this one into positive. Okay. The rest of the number is the same. All right. How about this is called a pure number? This is called a pure number. Okay, pure imaginary number. I'm sorry, pure imaginary number. So I don't have an A part. A is 0. Look at that. This A is 0 in here, right? So what is my conjugate? My conjugate will be negative AI because my A is 0. So this is my conjugate in here. Okay. All right. So the reason we want to this called a conjugate. There's a reason for that. The product for all of this, it will become a real number, okay? The product of a complex number and its conjugate is a real number. So look at this one right here. If I have an AI times negative AI, let's look at the easiest one, okay? And I will have a negative 64i squared. Look at it. 8 times 8 is 64, right? And I carry the negative over. And how much is I squared? Well, now I squared is negative 1. Okay, so if I multiply these two together, I got positive 64, which is a real number. I is gone. Look at that. This one, I is gone. Okay, so that's why, multiply the conjugate become a real number in here. Okay, so that is very important in here. Look at this one right here. If I have a 5 plus 7i, and then I multiply the conjugate in here, I multiply the conjugate, which is 5 minus 7i in here, right? This one multiply, it will become a real number at the end, okay? So you don't have to do the FOIL. This one, we're gonna using a plus b times a minus b. Look at it. If I have a plus b times a minus b, what do I get? This is called the difference of the product, okay? This one, there's a formula for that. This is a squared minus b squared, okay? Because if you go to do the FOIL in here, if you go to do a little bit FOIL, right? There's b times a in here. There's a b times a in here. This is positive. This is negative. These two gonna be canceled out. So you're gonna have only the first term and the last term there. So that's why you have a squared minus b squared. This is very, very important, very, very helpful. So we use it for this kind of conjugate, okay? So when I have a plus b times a minus b in here, right? So this is a conjugate. So my answer will be a squared. My a is 5 minus b squared. My b is 7i. My b here is 7i. Okay, so using the formula in here. All right, so this one you will get a 25 minus 49i squared. I squared is -1, right? And then negative become positive. So I have a final answer is 74. Look at that, 74 is a what? Is a real number. It's not a complex number anymore. So that is the beauty of multiply the conjugate here. Multiply the conjugate, you got a real number. So anytime when you multiply the conjugate, you got a real number in here. You got a real number. Okay. All right. Another thing here is similar. We multiply these together, right? We got a real number. AI times negative AI. And then we got a negative 64i squared. And then I squared is -1. So we have a positive in here. All right. I was showing you a little bit. If you don't use the formula, what do you get? You're gonna do the FOIL, right? So 5 times 5, what do we get? You got 5 squared. Okay, you got 5 squared in here, and then you're gonna do the FOIL. 5 times this one right here. You're gonna have a negative 35i in here. Okay, that's the outer one, and then the inner one right here. You have a 7i times 5, you got plus 35i. Okay, and then the last one right here, this is the last one right here. Okay, so 5 times -7, you got negative what? Oh, I'm sorry, not this one. Not this one in here. We already have this one. It's this one right here, this one. Okay, that's using a different color. All right, 7i times -7i in here. Okay, now that one. That one, we already have an orange in here. All right, so that is minus what? Minus, this is negative, this is positive times negative, so it's 7i plus 7i times -7i. If I write down one more step in here, but as you can tell, these two middle one cancel out, these two middle one cancel out. So we're gonna just have a 5 squared, and then minus 7i squared in here. Okay, so we got the same answer in here. So let's do the FOIL, but you don't have to do this FOIL. When you see this one, this is a plus b times a minus b. We're gonna using the formula right away. Okay, using the formula right away is a squared minus b squared. That is the quick and easy one. Okay. All right, so we're gonna do a little bit of division in here. This is a very common question on the test or in the homework on the last part. Okay. If I want to rationalize the denominator, so what does rationalize the denominator mean? That means if I have a 2 minus 5i, okay, divide by this one right here, divide by this one right here. I don't want an I in the denominator. So what can I do? I want to write down the standard format. We want to write down this one called a plus bi, right? So we don't want an I in the denominator. So what do we do in here? This is a very common question on the test. Okay, so we call this one called multiply the conjugate. Multiply the conjugate of the denominator. Okay, multiply conjugate of the denominator in here to get rid of I. All right, so my denominator is 1 minus 6i. So what is the conjugate? Conjugate will be 1 plus 6i. But you have to multiply the same thing on the numerator. We call this one is multiplied by 1, right? Anything, look at that. If I have 100 times 1, what do I get? I still got 100. I still equal to the previous one. So that's why we can have an equal sign. All right, so you have to, so this one can be what? This one can be 2 over 2, right? 2 over 2 is 1. So this will be all equal in here. So that's why when you multiply the conjugate, you always have to multiply, numerator and denominator are the same, right? So when we multiply this one, and then we can FOIL this one in here. Okay, so this is all the parentheses in here. All right. So my denominator, very quick, is a plus b times a minus b. So I will have a squared minus b squared which is 6i squared. That's my denominator. Look at that. So I can get my denominator out really quick, right? So this one squared is 1, and then minus 6i will be 36i squared in here. Okay, and how much is the I squared? I'm going to go ahead and finish the denominator. I squared is -1, right? -1 in here. So now we have a, 1 minus this one. So this will be 1 plus 36 in here because negative become positive. So my denominator is 37. Look at that. So this is called rationalize the denominator. My denominator is a real number, don't have I anymore. Okay, if I multiply the conjugate, my denominator will be a real number. And we have to go back to figure out how much is on my numerator. Well, on my numerator, I have to FOIL it in, right? So 2 times 1, I got 2, okay? And then 2 times 6i, we got a 12i, okay? This one doesn't have a formula because it's not a plus b times a minus b. So we have to FOIL it in here. And then we're going to do the inner one. So -5i times 1, we're going to have a -5i in here, right? And then the last one right here, is -5i times 6i. So this will be -30i squared. Remember, we have an I here, so it'll be I squared, right? So go ahead and do the a little bit like a term in here. 12i minus 5i, that is 7i. Okay, that's 7i in here. And then minus 30. Remember, I squared is -1. Okay. All right. So what do we get in here? We got 2 plus 7i. Negative become positive. So that's positive 30. All right. So 2 plus 30, we got what? We got 32 plus 7i. Okay. So that's it. That's the answer in here. All right. So we get rid of I in the denominator. We don't have I in the denominator. And sometimes the question says, if you want to write down A plus BI, how do you write down A plus BI form? How do you write down this standard form? Well, if I want to write down a standard form, I will just each one write down divided by the denominator, right? So I will have a 32 divided by 37, and then plus 7 divided by 37i. So I have this one called A plus BI. Look at it. My A is 32 over 37, right? My B is 7 over 37. So that is this one. Of course, if this can simplify, you have to simplify, but I cannot simplify this one right here. So that's it. That's the final answer in here. Okay. That is all about the fourth section 3.1. So we talk all about a complex number. Okay. Because when we talk about quadratic later on, it might not have a real solution. So if we don't have a real solution, we have to use the complex number I in here. Okay. All right. Any questions? All right. I'm going to stop recording because this is all that I want to talk today. Okay.